In the last video, we learned that crude oil is a mixture made up of many different hydrocarbons, and that these hydrocarbons can be separated based on the length of their carbon chains using a process called fractional distillation. We also discovered that the shortest chain hydrocarbons are the most flammable, which makes them ideal as fuels, while the longer chain hydrocarbons are much more viscous, meaning they are thick and sticky, and are therefore less useful for fuel applications. In today's video, we're going to focus on how these longer, less useful hydrocarbons can be broken down into shorter, more flammable ones using a process called cracking. Cracking is essential in the petrochemical industry because it helps us maximize fuel production and generate valuable byproducts. Cracking is a type of thermal decomposition reaction. If we break down this term, thermal refers to heat, and decomposition means breaking a substance into smaller parts. Therefore, thermal decomposition simply means breaking down molecules by applying heat. There are two main types of cracking that you need to know: catalytic cracking, steam cracking. Regardless of the method used, the first step in cracking is to heat the long-chain hydrocarbon until it vaporizes, meaning it changes into a gas. In catalytic cracking, this vapor is passed over a hot powdered catalyst, commonly aluminum oxide. As the hydrocarbon vapor comes into contact with the catalyst, the large molecules split apart into smaller molecules, resulting in a mixture of shorter hydrocarbons. In steam cracking, after vaporizing the hydrocarbon, it is mixed with steam and then heated to a very high temperature. This intense heat causes the long chains to break apart, once again producing shorter hydrocarbons. Aside from understanding how cracking works, you are also expected to be able to write balanced chemical equations to represent these reactions. Let's look at an example using decane, which has the molecular formula C10H22. If we crack this molecule, one possible product is heptane, which is C7H16, and another product is propene, written as C3H6. It's important to note that the number of carbon atoms and hydrogen atoms must balance on both sides of the equation, just like in any other chemical reaction. So if decane has 10 carbon atoms and heptane has 7, the other product must have 3 carbon atoms to balance. For the hydrogen atoms, if decane has 22 and heptane has 16, then the other product must contribute the remaining 6 hydrogen atoms. However, this leads to an interesting point. There are not enough hydrogens left to make the second product a saturated hydrocarbon with only single bonds. Therefore, the second product must contain a double bond, which makes it an alkene, not an alkane. Although alkenes may seem like side products, they are actually extremely valuable. Alkenes are used to produce polymers like plastics and also serve as starting materials for the manufacture of many other important chemicals. Let's now walk through a worked example. Suppose decane, C10H22, is cracked to produce ethene, C2H4, and one other product. To write a balanced equation, we begin by writing what we know. Decane breaks down into ethene and an unknown hydrocarbon. To find the unknown, we simply subtract the atoms in ethene from those in decane. For carbon, 10 minus 2 equals 8 carbon atoms. For hydrogen, 22 minus 4 equals 18 hydrogen atoms. So the other product must be C8H18, which is octane. The complete balanced equation is C10H22, C8H18 plus C2H4. Before we finish, let's highlight that alkenes like ethene and propene form another homologous series. This means they are a group of compounds with similar chemical properties and the same general formula. The key structural difference between alkanes and alkenes is that alkenes contain at least one double bond, while alkanes contain only single bonds. Therefore, alkenes are classified as unsaturated compounds, whereas alkanes are saturated. This double bond in alkenes makes them more reactive than alkanes. There are two important things to know about alkenes. Alkenes decolorize bromine water. If we add bromine water to a solution that contains an alkene, the orange color disappears, turning the solution colorless. This reaction serves as a chemical test for alkenes, and you should remember it for your exams. Alkenes are used to make polymers. The double bonds in alkenes can open up and form new bonds with neighboring molecules, allowing them to link together into long chains called polymers, which are the building blocks of many synthetic materials such as plastics. In summary, Cracking is a vital process that transforms large, less useful hydrocarbons into smaller, more useful ones, including alkenes, which are not only important for making fuels, but also for manufacturing plastics and many other chemicals. Alkenes are unsaturated, more reactive, and can be easily identified using the bromine water test. That's all for today's video. We hope you found it informative. If you did, please share it and subscribe for more. We'll see you in the next lesson.